So anyway, he's claiming that a 4 mass with 1 velocity has the same energy as a 1 mass with 2 velocity. It's nonsense, but whatever. It doesn't represent the truth. The truth is that one atom moving 1,000 miles an hour has exactly the same ability to share energy with the universe that 1,000 atoms moving 1 mile an hour has. It's the same capacity to do work. So if you don't have the masses much heavier than the device you're using to swing it, obviously the experiment is going to be crap. All right, so he didn't do any of that. So what he has is a lever that probably weighs more than the weight he put on the levers. So
I have changed the aluminum pendulum with a carbon stick, my carbon rod. It's still suspended to the nail over here with a little nut fixed at the top. So this is the actual weight of the carbon rod. It's only 3.10 grams, so it's almost nothing. Very lightweighted. So the center of mass should be way down below here at the bottom. Now that I have these batteries, they weigh a lot more than the carbon tube.
So what he's doing is he's expanding a rubber band that's for some reason connected in some weird way here.
So this is a rubber band. I have one nail over here, one nail over here. So normally, if you wonder why it's a weird setup, it's because when you put the rubber band over the nails, we actually have two strings. So I put this one on another nail so that we only have this one piece, right? This one string. So that's why it's a triangular.
So the surface he's pushing into the rubber bands is a different surface, okay? It makes a difference whether this surface or this kind of surface hits the rubber band.
I'm going to record from the sides with the GoPro camera is going to be over here because I'm going to, it's the bottom of the, hold on, the bottom of the tube here, of the stick is going to push against the rubber band. We always want the same surface to be pushed against the rubber band, and in the previous trials it was the batteries themselves that were pushing against the rubber band. And so when I had the 4 mass, it was like this much of a surface pushing against the rubber band, and that was probably a flaw, that I admit. So now it's only the stick itself, the bottom of the stick pushing against the rubber band.
So what he's obviously done is, and he's doing this horrible measuring thing still, where instead of having a precise measurement, he's using a chart behind the object, and just eyeballing it, when he should be using some kind of standard heights, that are guaranteed each time to get the same exact amount of energy, but they won't do those kind of things.
I hammered a nail in here, all right, so that I can let it drop from a fixed position each time. So about the center of mass, I guess the center of mass is now at the middle of the batteries, so that's where the baseline is, around the middle of the battery. And so when we follow the curve, the center of the batteries is always aligned with this curve. All right, all the way up to here. So I think that's pretty much okay. Holy damn. Whoops, lots of noise outside again. This is the weight of the 1 mass, 52.30 grams. This is the 2 mass, 106.15 grams. So it looks like this. 4 batteries and a little coin at the side. So and the pendulum is in the middle, so normally the center of mass is in the middle. Okay. This is the mass of the 4 mass, 209.4 grams. A close-up of the 4 mass. So I hope that the center of mass is in the middle. Quick thing about the ruler. So I have it over here. So the 0 mark is at where the rubber band is. So you can see it's quite perfect. And then the GoPro, yeah, well, hold on. Your GoPro can see, you can see through the GoPro that the bottom of the carbon tube, you can see it where it is at the ruler. So that should work out. This is the 1 mass, 2 velocity, 5 trials. Okay. One, 2, 3, 4, 5. Now I'm going to let the 1 mass drop from the 1 velocity mark, because normally, theoretically, when dropped from the 2 velocity mark, it should produce twice the amount of stretch as when dropped from the 1 velocity mark. So let's find out. And I think also that draft science agree with this, that when it goes twice as fast, that it will produce twice the amount of stretch. This is the 4 mass going 1 velocity. So also a nail over here, so that we have a fixed position, fixed height. Right. One, 2, 3, 4, 5. And now I'm going to let the 2 mass drop from 1 velocity. Record. 1, 2, 3, 4, 5. All right.